Good morning, children. Welcome back. So, in the last class, we discussed about the different physical quantities, classification, and units, system of units, classification of units, and what are the ranges of physical quantities, different range in the case of length, mass, time, and how we will measure the smaller length, larger length, all these things we discussed in the last class. Okay, and what is the relationship between the common unit and the range, that is how can we represent Armstrong with a meter or light year with a meter, then mass with the kilogram and kilogram, how can we relate, all these things we discussed in the last class. Now I am introducing the prefixes for powers of 10. So in the large measurement and small measurement, here we will represent the unit or the quantity as the multiples of 10. So suppose you are getting a quantity as 300. So instead of writing this 300, we are writing it as 3 into 10 raised to 2. That is as the multiples of 10. That is powers of 10. As the powers of 10, we are representing the physical quantities and units. So what are the commonly used prefix and how we will represent it, and how is it related with the powers of 10? Then we have to know, then only we can represent all the physical quantities which we are going to discuss, okay, in our physics topics. So here there is a table and you have to write this in your book and you have to study it properly. So what is it? Here are the multiple, prefix and symbol, and here the submultiple, prefix and symbol. Okay, how we are representing that. So here first one, 10 raised to power, 10 raised to 1. That is the power of 10, here it is 1. And it is known as deca, and we are representing it as small letter dA. And second one is 10 raised to 2. 10 raised to 2, it is hecto, and it is represented by small letter h. And 10 raised to 3, it is kilo, and it is small letter k. That is, we are using this. Like the other two, it is not that much common. But the third one, 10 raised to 3, it is kilo, kilogram, kilometer. All these things we are using. So it is, power is 10 raised to 3. That is, here we can write, if it is 3000, we will write it is 3 into 10 raised to 3. Okay, 3 into 10 raised to 3. That is kilo. Then 10 raised to 6 is mega. It is known as megawatt. Megawatt, we are using that. And it is represented by capital M. And 10 raised to 9, it is giga and it is G. Okay, gigabyte. That is how many, what is the quantity is 10 raised to 9. That is 10 and how many zeros? 1 and 9 zeros. 10 and 8 zeros. That is giga, that much big quantity. Then 10 raised to 12 comes, it is tera, it is capital T, and 10 raised to 15 is its beta and capital P, it is representing symbol. 10 raised to 18 is exa and it is represented by capital letter E. Okay, the commonly used ones are 10 raised to 3, 10 raised to 6, 10 raised to 9 and some cases 10 raised to 12. Okay, 3, 6, 9, we are generally using that. And the submultiple, that is here 10 raised to 1 and here it is 10 raised to minus 1. What is that 10 raised to minus 1? 1 by 10. Okay, 1 by 10 is 10 raised to minus 1. That is deci. That is small letter d. That is our decimal point, 1 by 10. Decimal system, 1 by 10. So it is deci and small d. And 10 raised to minus 2. Here 10 raised to 2, 10 raised to minus 2, it is centi. That is our centimeter, meter centimeter relation. And it is c, small c. Then 10 raised to minus 3, it is milli, small m. 10 raised to minus 6 micro, it is mu. This is not m, it is mu. This symbol is mu. Okay, then 10 raised to minus 9. 10 raised to minus 9, it is nano. It is known as nano and it is represented by small letter n. The next one is 10 raised to minus 12. It is pico and it is p, small p. 10 raised to minus 15, femto f. That is our Fermi, isn't it? Size of the atom. It is in the order of 10 raised to minus 15. That is femtometer and we are calling it as, it is also known as what? Fermi. Fermi. Then 10 raised to minus 18, it is Otto and it is A, small letter A. So these are the prefixes for powers of 10. Okay, and here the submultiples we are commonly using. Femto we are using when we are discussing about the atoms and all, the nano, micro, milli, centi, deci and all. And in this side kilo, mega, giga, all these things we are using. Okay, so you have to an idea about this prefix and how what we are calling for that. Okay, what is the name of that? So here I will explain some examples. See, ohm. What is the ohm? Ohm is the unit of resistance. You know that ohm is the unit of resistance. So 1 mega ohm. 1 mega ohm. How will you write 1 mega? It is represented by capital M. Capital M ohm. Oh, this is the symbol for ohm. Okay, and 1 mega ohm, how is it related with the unit ohm? Ohm is the standard unit of resistance, isn't it? So 1 mega ohm is equal to 10 raised to 6 ohm. That is, it is equal to how much? 1 into 10 raised to 6. 1 into 10 raised to 6 ohm or 10 raised to 6 ohm. But 3 mega ohm. 3 mega ohm is equal to how much ohm? That is 3 into 10 raised to 6. 100 mega ohm. 100 into 10 raised to 6 ohm. Okay. Then kilometer. 1 kilometer. It is represented by 1 km. Kilometer. And 1 kilometer, how much meter it is? 1 kilometer is 1000 meter. That is 10 raised to 3. 10 raised to 3 meter. So 5 kilometer is, instead of writing 5000 meter, how will you write? 5 kilometer is equal to 5 into 10 raised to 3 meter. 20 kilometer, 20 into 10 raised to 3 meter. 100 kilometer, 100 into 10 raised to 3 meter. So kilo comes, what is it? Into 10 raised to 3. Okay, then here deca. Decagram. Deca means how much? Deca is 10. So 1 decagram. Deca is represented by dA and it is G. So 1 deca is 10 raised to 1. 10 raised to 1 is 10. So it is 10 gram. Then nanosecond. NS. N for nano and S for second. So 1 nanosecond is 10 raised to minus 9 second. For 5 nanosecond is 5 into 10 raised to minus 9 second. 100 nanosecond is 100 into 10 raised to minus 9 second. Then milli. 1 millivolt is equal to 10 raised to minus 3 volt. Okay, 10 raised to minus 3 volt. Understood? So same way we can write, or everything we can convert. Okay. Everything we can convert. Okay, so you have to write this in your notebook. So write down this as the heading, prefixes for powers of 10, and draw this column and copy this. Okay, in your notebook, physics notebook, and study that. This column is enough. The other one is the example. Okay, all of you do that. Okay, so let us move to the next portion. You take your textbook, page number 35. You can see that exercise. And in that exercise, 2.1 and 2.2, filling the blanks questions. First one, the volume of a cube of side 1 centimeter is given is equal to dash meter cube. So that there are 8 questions. So that you have to do as the homework, or this depends upon the this conversion. Okay, centimeter to meter conversion, then centimeter to millimeter conversion, kilometer hour to meter and second, all this conversion. So you try to do that, and if you have any doubt you can contact me. Okay, I will explain you how to do. You try to do that. In the next class I will explain the answer. Okay. As an example, that exercise question, we can discuss one problem. So you write down the question. Convert an acceleration of 2 kilometer per hour square. 2 kilometer per hour square. You can write like this, or 2 kilometer per hour square into centimeter per second square. Centimeter per second square. Okay, two method. You can write divided by r square or x raised to minus 2 per second square, or second raised to minus 2. Okay, so convert 2 kilometer per hour square into centimeter per second square. So how to convert this? If you are after discussing this problem, that exercise question will be easy for you. Okay, so let us see how to solve this. Here a is equal to nu, where n is the numeral and u is the unit, isn't it? And we studied that as the unit increases, the numeral decreases. So same thing, I am using the prefix as the conversion, we can do this. So how is it? Here what you have to do? You have to convert first kilometer to centimeter. Okay, kilometer to centimeter. So we have in the 1 meter is equal to 100 centimeter. So as the prefix it is 10 raised to 2 centimeter. Then 1 kilometer, here we have kilometer, and 1 kilometer is equal to 10 raised to 3 meter, that is 1000 meter. 1 meter is 10 raised to 2 centimeter. So 10 raised to 3 meter is 10 raised to 3 into 10 raised to 2 centimeter. So how much it is? 10 raised to 3 into 10 raised to 2. 3 plus 2, it is 5. 10 raised to 5 centimeter. So the direct relation, kilometer to centimeter. 1 kilometer is 10 raised to 5 centimeter. So here 2 kilometer. So 2 kilometer is how much centimeter? 10 raised to 2 into 10 raised to 5 centimeter. Okay, 2 into 10 raised to 5 centimeter. Next, what is it? Hour square to second square. Okay, hour square to second square. So what is it? 1 hour is equal to 60 minutes. And 1 minute is 60 seconds. So 60 minutes is 60 into 60 seconds, that is 3600 seconds. That is 60 minutes, that is 1 hour. 1 hour is equal to 3600 seconds. So this is the relation between hour and second. So here hour square is there, 2 hours are there, isn't it? So that is 3600 into 3600 second square. Second into second, so it is second square. Okay, then simplify this. On simplifying, you will get the value. Okay, so simplifying, so how is it? 2 into 10 raised to 5 divided by this. We can write it as the multiples of 10. So it is easy to simplify. 36 into 36 into how many zeros? 1, 2, 3, 4. 36 into 100, 36 into 100. So 2 hundreds are there, that is 10 raised to 4. This 10 raised to 4 goes the numerator, what is it? 10 raised to minus 4. So this comes 2 divided by 36 into 36 into 10 raised to 5 into 10 raised to minus 4. Okay. So what is it? 10 raised to 5 into 10 raised to minus 4 is 2 divided by 36 into 36 into 10 raised to 4. Oh, sorry, 1. 5 minus 4 it is 1. We just divide this. 2 by 36 comes 1 by 18. 18 into 36. On simplifying, you will get it as 1.543. You just multiply and see. Into 10 raised to minus 3 into 10 raised to 1. This comes on simplifying. It comes in the powers, that is 0.00154. It will come. So it is equal to 0.0154 centimeter per second square. So this is the conversion. Till here only this is the new one. Next step, it is only the division and the multiplication. Okay, so 2 kilometer per hour is equal to 0.0154 centimeter per second square. Okay, so this is the example. So the homework question which I gave is based on this. So just do the conversion and substitute it and simplify. You will get the answer. Okay, it is very easy. And the next question is why we are going for this conversion. If it is given in centimeter, why can't we do it in centimeter? Or if it is in millimeter, why can't we follow that millimeter? It is not like that. That is when we are doing a calculation, simplifying something, what is it? All the units should be in same system of units. All the physical quantities should be in the same system of units. Here we are following the SI, isn't it? System of International. So there we know mass is in kilogram, time is in second, length is in meter. All these things we studied, isn't it? Temperature is in Kelvin. So if it is given in two different systems, units are given in two different systems. For example, what is it? Length is given in centimeter, 5 centimeter. Length is in 5 centimeter and what is mass? Mass is in kilogram. Okay, mass is in kilogram and length is in centimeter. We can't follow this physical law here, isn't it? So what is it? We have to make either everything in the SI or everything in the CGS. Centimeter is given means we can follow the CGS system also. So that what you have to do, you have to convert that mass given. It is given in kilogram, that you have to convert to gram. Then you can do the required calculation. And or you can convert that centimeter to meter. Centimeter to meter and kilogram. You can do the calculation. Okay, that's a physics rule we can apply. Suppose you want to find out the force or you want to find out the momentum. Momentum is mass into velocity. So mass is given in gram and velocity is in meter per second square, meter per second. You can't do it. What is it? That gram you have to convert to kilogram. Then you can use the equation. Momentum is equal to mass into velocity. Understood? So that is why this conversion is very important. You have to make all the quantities given, physical quantities given in a same system of unit. Okay, it may be CGS system or it is SI or it is MKS, any systems which you studied. Okay, but generally we are following the CGS system and SI. So CGS to SI and SI to CGS conversion you have to know. So for doing all this conversion, this prefix which we discuss is very important. So you have to study that. Okay, so next we are more and you do the problems which I gave homework, you try to do. Okay, any doubt you can contact me. Our next topic is accuracy, precision and errors of measurement. In the measurement, we know, isn't it? Measurement is the important thing, that is in physics, using the science development in the technology. I told you we can measure the smallest one and the largest one, isn't it? So the measurement is a very important thing in the physics, isn't it? We are I told you we are not approximating. We need the correct value. So that is why we are going for the measurement. So it is a technique of determining the magnitude of each and every physical quantities measurements. Okay. So in that measurement, we have to discuss about accuracy, precision and errors. So first we can discuss what is accuracy and precision. What is the difference between accuracy and precision? So for every measurement, suppose we are measuring length of this pen. So there is a correct value, isn't it? There is an actual length for this pen. So that actual length, it never changes, isn't it? It never changes. It will be a constant one. That value, it is known as its true value. True value. It is the true value. That is the actual value or the true value of this pen. That is any physical quantity. Okay. Then I am measuring this. I am measuring this. Suppose the length of the pen is, it is 15 centimeter. Its true value is 15. More precise, it is 15.25 centimeter. This true value is 15.25 centimeter. That is the correct true value of this pen's length. Okay. Then I am measuring this. I am measuring this with a scale, a very good meter scale I am having, and with that scale I am measuring this. And in my first measurement I got this as 15.20 centimeter. 15.20 centimeter. Okay, and I am having another scale, and in that this 0.5 divisions are not there. Using that scale I measured and I got the value as 15.2 centimeter. 15.2 centimeter. Then I went for a third measurement, and there I am using another device, another measurement scale where all the millimeter marking is there. So I got it as 49 centimeter. Okay, 49 centimeter. So here you can see that it is all the values are somewhat near to this value, isn't it? But we can say that this 15.20 centimeter and 15.249 centimeter are more accurate because it is very close to this. Okay, very close to this true value. But see, sorry, yeah, take as 2, 3. 2, 0 comes. Okay, 2 comes. So 2, 3, it is the accurate value. And here I am getting it as only 15.2 centimeter. 15.2 centimeter, and here there is a difference of how much? 0.05 centimeter difference is there, isn't it? Difference is there. So the first two measurement which I done, it is accurate, and out of these two accurate value, I can say this one is more precise. This one is more precise. It is very close to the true value. Precise. Okay. So accuracy and precision. So this here in this measurement there is some error. Okay. There is some error. That is maybe my error. That is while taking the reading I made some mistake, or it is the error of the instrument which I used. Anything may happen. Okay. So accuracy and precision. So accuracy means how close the measurement is to the true value or the actual value of a quantity. Okay, and in accuracy there is some variation may happen. that is because of the person who is doing the measurement, or the error in the, or the mistakes, or the what is it, problem with the devices which we are using for the measurement. Okay, and precision means it depends upon the, mainly it depends upon the measuring device. That depends upon the least count of the measuring device. It depends upon the least count of the measuring device. What do you mean by the least count? Least count is the smallest measurement which we can do with an measuring device. Smallest measurement which we can do with a measuring device, that is known as its least count. So here see the difference. Here only I can measure that 0.01 centimeter. 0.01, 0.02, like that I am getting 15.23 here. And here in this device which I used here, I can go for the measurement 0.001. Isn't it? 0.001, 0.002, 3, 4, 5, like this I am getting it as 15.249. Isn't it? And here, what is it? Here it is 15.23. Here the least one is 0.01 centimeter. So in your scale, this scale, okay, centimeter scale. So here what is the least measurement you can do? So here this is a centimeter scale, and here from 0 to 1, isn't it? That is a 1 centimeter. And in between you can see that small divisions, isn't it? Small divisions, that is first to here near to this 0 line you can see a small line, then comes a big line, so that we are taking it as the 1 millimeter, isn't it? So like that big lines, and here center is little bit big line you can see, that is 0.5 millimeter, isn't it? 0.5 millimeter, and here 10 millimeter, that is equal to what? That is equal to 1 centimeter, isn't it? 1 centimeter is equal to 10 millimeter. And here in that 1 millimeter you can see one more division, that is the 0.5 millimeter. So using this scale you can measure a length of 0.5 millimeter. Can you measure this 0.1 millimeter using this scale? No, we can measure only 0.5. That is the least measurement which we can do with this scale. That is 0.5 millimeter. Okay, then 1 millimeter, 1.5 millimeter, 2 millimeter, 2.5 millimeter, like that it is continuing. Then last it makes 1 centimeter, 2 centimeter, and that division you can see in the first two, 1 and 2 only it is there, that is 0.5 millimeter division. And the next here it is 1, 2, 3, like that, that is like 10 divisions only. Understood? So here the least count of this scale is 0.5 millimeter. Okay, 0.5 millimeter. I can't measure 0.1 or I can measure 0.01 millimeter using this scale. So that is the least measurement. So that makes the value more precise. Okay. Smaller the measurement, we will get the very small values. Okay, that is the very close values to the near to the true value. Understood? So accuracy and precision. So that is the two important terms related with the measurement. Accuracy, how much close to the true value our measurement, and precision, it depends upon the instrument, least count of the instrument which we are using. So you can write the next question. Define accuracy and precision. Define accuracy and precision. And write down accuracy. Side heading you write accuracy and write what is accuracy. It refers to the accuracy. It refers to the closeness of the. Refers to the closeness of the. Refers to the closeness of the measurement of the. Closeness of the measurement of the true value of the measurement of the closeness of a measurement. It refers to the closeness of a measurement to the true value of the closeness of a measurement to the true value of the physical quantity. True value of the physical quantity. True value means it is the actual value of the quantity. Next is precision. Next is identifying precision. It refers to the resolution. It refers to the resolution or the limit. Resolution or the limit to which the quantity is measured, or the limit to which the quantity is measured. It is determined by the least count of the measuring device. It is determined by the least count of the measuring device. The smaller the least count, greater is the precision. Okay, greater is the precision. The least count is more, but is it the precise value also more? Okay. So next we have to, you write down the next question. What do you mean by error in a measurement? Next we have to discuss about error. What do you mean by error in a measurement? So error. So we are doing the measurement. We are measuring a physical quantity with the measuring device, isn't it? Measuring device. So using the measuring device, some uncertainty may happen. Okay. That is, there is a difference between the true value and the value which we measured. So that uncertainty, we are calling it as the error. Okay. That uncertainty, we are calling it as the error. Okay. So while taking a measurement, what is it? Because of many reasons, many problems are there. That is our fault. That's while taking the reading, our concentration is lost and we are doing some other reading, or that with the instrument some problems are there. Everything may cause a difference in the measured value and the actual value or the true value of the physical quantity. So that difference we are calculating as the error. Okay, that is the uncertainty occur while measuring. That is known as the error. So for example, so last year you have done that Ohm's law experiment. Ohm's law experiment, what is it? We are calculating the resistance of a resistance coil. Isn't it? That voltmeter, ammeter, everything you connected, and we use the equation R is equal to V by I. From the voltmeter, we found out the voltage, and ammeter, we found out the current, and that ratio is the resistance. Okay, so you are having some readings, and suppose the resistance of that coil is 3 ohm. Resistance of the coil which you used is 3 ohm. And here in 5 measurements we are doing 1, 2, 3, 4, 5. In each cases you are finding out R, and the first one you are getting it as 2.9. Then next it is 3.1. Then 3.1 you got. Then 2.8 is the next value of resistance, and 2.75 is the fifth value of resistance. Okay. Here we can see here we got 3. So these are the readings which you got, the result which you got in that Ohm's law experiment. You remember that, isn't it? And here you can see that in each calculation, in each measurement, what is it? There is a difference, isn't it? And here instead of 3, you are getting 2.9. So here the true value is 3 ohm. And what is the measured value? Measured value is 2.9. So what will be the error in the first reading? The first calculation, what is the error? Error is equal to true value minus measured value. True value minus measured value. So here, what is the true value? 3. 3 minus 2.9. Isn't it? So what is the error happen here? It is 0.1 ohm. Isn't it? It's in ohm. 0.1 ohm is the error in the first measurement. And in the second measurement, it is 3.3 minus 3.1. It is minus 0.1. Minus 0.1. And the third case, it is 3 minus 3. It is 0. No error. Isn't it? And the next case, 3 minus 2.8, it is equal to 0.2. And the fifth case, what is it? 3 minus 2.75, it is 0.25. 0.25. Okay. So yeah. Fourth case, it is 3 minus 2.8, it is 0.2. So in each measurement, there is error. Here 0.1, here minus 0.1, 0 and 0.2, 0.25. Okay. So that is the difference between the true value and the measured value. So that is why we are going for the number of observations, minimum 5. Your teacher told you to take a minimum 5 observations. Because when we are doing these observations, actually the average of the result which we are getting, that we are considering as the true value. Is the true value. Okay, so here we will find out the mean of this, average of this, that we are considering as the true value. But any experiment you are going for the measurement, we will take a set of readings and we will find out the average. It should be in the order. Okay, it is near to the actual value. And we will find out the mean, and that mean is the true value. And from that average or the mean value, we will find out what is the error in each measurement. Okay, so that is the error of a measurement. So the value, a physical quantity, we can represent, that is A is the physical quantity, we can represent it as A plus or minus delta A. A plus or minus delta A. Physical quantity, we can write it as Z. Z is equal to A plus or minus delta A. What is this? A is the true value. A is the true value, and may possible some error may occur. And what is that range? That range is plus or minus. Here you see, here it is plus 1 and plus 0.1, and here it is minus 0.1. So from the actual value, it's above or below, it may occur, isn't it? Or we will get like that. So the measured quantity, we will write it as A plus or minus delta A. So this is the, what is that? Permitted error. We can say that it is the permitted error, that is delta A, that is the variation. And that delta A should be, delta represents what? It is the small quantity, and it should be very less. Okay, it should be negligibly small, then only we can consider it as the correct physical quantity. If it is very big, means what is it? It is not error. At that time we will say it is the mistake. Okay, at that time it is the mistake. Now it is the error, that is delta A plus A plus or minus delta A. Delta represents a small quantity. Okay, all the small quantity, very small quantities are represented by delta. Delta A, delta B, delta C, whatever it is. Okay, delta X. So delta represents a small quantity. Understood? So how can we define error? Simply we can say error, it is the difference between the true value and the measured value or actual value of a physical quantity, and what is it? the measured value. That's the value which we are getting after the measurement. Okay, so that is error. So write down the answer for error, definition for error. Error in a measurement, error in a measurement is equal to the difference between the true value and the measured value. True value and the measured value of the quantity. True value or measured value of the quantity. You can write this. Error is equal to true value minus measured value. True value minus measured value. So to calculate error, we are using this relation. Okay, true value minus measured value. That is error. Now we have to discuss about the different types of error. Different types of errors are there. Okay. So error mainly that is because of our problem or the instrumental problem. Accordingly, it is classified error. Okay. So what are the different types of error? So the errors. We know error, it is the difference between the true value and the measured value. And errors are of classified different types are there: systematic error, random error, least count error. Systematic error, random error and least count error. Systematic error means what? It is error occur in a systematic way. It is error occur in a systematic way means that is here we have seen that it may be plus or minus, isn't it? So if it is plus, in the first measurement we got it as plus 0.1, plus 0.1 and minus 0.1 we have observed. So we are getting it as plus 0.1 in one reading, and every time it is in the one direction, the positive direction, or it is in the negative direction. So in a systematically that error occur, that is the systematic error. And in that systematic error are of three types. One is the instrumental error, and imperfection in experimental techniques, and a personal error. It is classified into three. And what is the instrumental error? Instrumental error, it is the problem with the instrument which we are using for measurement. That is the instrumental error. Suppose the marking is not done properly. Okay, not done properly, and you are the least count or the zero coincidence or the minimum value. That is, for example, voltmeter you are using. You used voltmeter, isn't it? And there is an indicator in the voltmeter. And in that indicator, if no current flows, the potential flows, what is it? It should be at 0. And by some imperfection, what is it? It may shifted from that. It is below the 0 or above the 0. So that causes, if you are not noticed that, what is it? That will cause an error in the value or the measurement every time, isn't it? So that is known as the instrumental error. That is, we are using not a proper instrument for measuring, that causes instrumental error. So what is it? While doing an experiment, we have to check all the instruments before, isn't it? If there is an error, so if error is there, we have to rectify that. Then only after that only we are going for the measurement. Okay, otherwise the experiment we are doing, that will be a waste. We won't get the correct value or the correct result we won't get. So that is the instrumental error. Okay, and the next one is imperfection in the experimental techniques. That is, we are doing the experiment, and if you are not connecting it properly or if you are not arranging it properly, that causes error. For example, you are measuring your body temperature, and to get exact body temperature, we have to keep it under the tongue. And if you are keeping it under the arm, what is it? The value of the temperature which we are measuring, it is always less than the body temperature. So which one we want to measure, we won't get the correct result. So the techniques which we are following, and here the circuits and all connection, if you are not making a proper connection, fluctuation will be there, that won't give you a correct result. Okay, so that experimental setup we have to arrange, and that last year you have done the lens mirror experiment, isn't it? And if you are not properly arranging that lens mirror screen source and all, if you are not aligning in a straight line, what happen? You won't get the correct image on the screen, isn't it? So that is the imperfection, so that we have to rectify. And the next one is the personal error. That is depends upon the person, those who are doing the experiment. That comes under this imperfection also, experimental technique also. So while taking the reading, we should be very careful. We should be concentrated what we are doing. Otherwise, it may cause what? Error in the measurement. Okay, so we won't get the result, actual result which we want. So such errors, so the same steps we are measuring, that instead of starting from the for example this mirror experiment, so we know what is it, u is the image distance, isn't it? It is the distance between the, sorry, u is the object distance, it is the distance between the object and the mirror, isn't it? So instead of measuring this distance from the object and the mirror, we are measuring the distance between the object and the screen, and you are marking it under u. Is it u value there? No, that is our personal error. And every time you will measure that the same way, that is systematically in that order, and we will get the wrong answer, isn't it? So that comes the personal error, and that is the imperfection in the experimental technique also. So that comes under the systematic error. And the next comes is random error. So what is random error? From the name itself it is clear, random error. So what is it? Randomly happening, isn't it? So that depends upon that voltage fluctuation. We are doing the electricity experiment. That voltage fluctuation gives you, what is it, not correct reading. Okay, the fluctuating reading we will get. So that randomly happening, isn't it? And the atmospheric condition, temperature, if you are doing the thermodynamic experiments, the atmospheric temperature and pressure may affect the reading observation. Okay, such errors are known as the random errors, randomly happening. And the last one is least count error. So I told you what is least count. So while making the device, instrument, measuring device, if there is an what is that, error in the least count in the measuring device, that cause error in the measurement also, error in our measurement also. That is called the least count error. If it is not properly marked, that will affect the precision of the measurement and the final result also. So that is known as the least count error. So this least count error is coming under both the random error and systematic error. In random error, it is in a single way only. Okay, that is a small scale only, it is coming under the random error, but it is a systematic error, least count error. So how can we rectify all these things? So this least count error and here the imperfections and all, by using a high precise measuring device. Very good measuring device with a very high technology if we are using, we can minimize error. Okay, so we are trying to minimize error. Then only we will get the actual exact value. For example, you are finding out the size of the atom. It is too small. In that it comes after so many decimal place. And in that, if you are making error, means the whole reading will be wrong, isn't it? So we should be very concentrated, very much concentrated in what we are doing. So like that we can reduce the error, and by using high quality measuring devices we can reduce the error. And we are going for a set of readings. I told you we are finding out 5 or 6 reading. An experiment we are doing, we are repeating it, we are taking the reading. Okay, and we are going for the mean value, that comes its true value. So that will help us to reduce the error in the measurement. Okay, so we will take many measurements, many readings we will take, and we will go for the mean, and that mean should be equal to the true value of the physical quantity which we are measuring. Okay, so that is about the error and its first classification, that is accuracy, precision, and classification of errors, that is the systematic error, random error, and least count error. So write down the next question. What are the different classification of error? What are the different classification of error? Okay. So next comes another classification, how to find out the error, how to find out the physical quantity, how to represent in terms of error, that we will discuss in the next class. So after the watching the video, you do the homework questions, that is the textbook and exercise you have to do, and write this answer also. So the next classification we will be discussing in the next video. Okay, any doubt you can contact me. So that is all for today. Thank you.